Hello everybody, in this video we will be identifying the x values that make a rational function undefined. We have this rational function here, the function f of x, that's equal to 2x plus 1 in the numerator over x plus 2 times the group x minus 3 in the denominator. And I want to know what values make this function undefined. What are the restricted values that are not allowed to be plugged into this function? And so this is a rational function. We really have to consider the anatomy of a rational function. A rational function is really just a giant fraction, if you notice. It has a numerator and it has a denominator. And what's one thing that we could never have in a fraction? Well, we can't have a denominator that's equal to 0. And so this denominator that I have right here, it can absolutely never, ever, ever be equal to 0, because when it equals 0, that makes the entire denominator equal to 0. And when the entire denominator is equal to 0, well, we have 0 in the denominator. Well, that's just not allowed. So, yeah. But let's see. What makes this equal to 0? That raises the question. What makes x plus 2 times x minus 3 equal 0? That's what I'm wondering. And so if we notice, that's just a quadratic equation in its factored form that needs to be solved. And the solutions to this quadratic equation that we have here will be the x values that make x plus 2 times x minus 3 equal to 0. We should all know how to solve a quadratic equation, especially once it's in its factored form, if we're at a point in math where we're dealing with rational functions. I'm going to use the zero product rule that says that if this times this is equal to 0, well, that means one of them is equal to 0, so x plus 2 equals 0, or x minus 3 equals 0, and that creates two basic little linear equations that are very easy to solve. Just subtract 2 from both sides, and we see our first value is x equals negative 2, and we'll add 3 to both sides, and we see our next value is x equals 3. So what are these values? We like to call these critical values because they're critical, they're very important. These are two different x values on the real number line in which I can never, ever, ever plug these values into my function here because it'll make the denominator 0. I can imagine if I put a negative 2 in here, well, that'll make this whole thing equal to 0. And 0 times anything equals 0. So if I put a negative 2 there, that makes the denominator 0, which is not allowed. And so that's why negative 2 is not allowed. Same thing goes if I put a positive 3 right here. That makes this whole thing 0, which makes the entire denominator equal 0, which again is not allowed. Those are the values that would not be included in my function. So I can imagine that this function's domain can consist of all real numbers except the two numbers negative 2 and 3. I can write it in interval notation saying that the x values range from negative infinity all the way into negative 2, but they jump over negative 2 because they're not allowed to equal it. They start right back up at negative 2 all the way until 3. They jump over 3 because they're not allowed to equal it. And then they start back at 3 and go on and on and on forever and ever, all the way until positive infinity. That would be the domain of this function. And as we see, we have two undefined values. They're the values when x is equal to negative 2 and equal to 3.